Um, I'll try my best. I was kind of confused on this one. Um, but I wrote out the problem and then I kind of tried to expand it to see if it would be easier, I guess, to solve. And yeah, so that's what I did in the second line. And then I kind of noticed that there were like certain ones that would like cancel each other out, kind of.
Okay.
Um, Yeah, and then after that, I was lost. But I kind of saw that my answer might be close to one of them, so I just tried it and it worked. So, yeah.
Okay. I love the way you started. Expanded notation is often a good way to go if you're not quite sure what else to do. And what I really liked was you followed that pattern that we showed you before, where you took your x to the negative third and you turned it into x to the negative 1 multiplied by itself 3 times. And I can see you got a little lost in the canceling, but you obviously got all the z's, right? You had your 5 z's on the top and your 4 on the bottom, and I can see where you boxed the one that was left. And so you have 1 z in the answer. So with the y's here, you have y to the negative 2 on the bottom, and I like it. You have both of your y's to the negative 1 here. What it looks like maybe you tried to do is to cancel these, right? The y's on the top and the y's to the negative 1 on the bottom, which we know kind of doesn't work, right? Because they aren't actually the same thing.
Yeah.
So what you would have ended up with all this stuff here, right? But what we do know about y to the negative 1, and actually let me show you with the x's because it's a little clearer. On the bottom, I have 2 x's here, and on the top, I have 3 x to the negative 1s. Well, we know that x to the negative 1 is equal to 1 over x. So if I replace this and I say, okay, I'm going to get rid of that, and instead I'm going to multiply by 1 over x, now I have another x on the bottom, right? And if I do that 2 more times, I have 1 over x and 1 over x. And now how many x's are there on the bottom, Mirta?
5.
And what do you think about the y's then, given what I just showed you?
You would bring both of the y's to the top of the equation. And then you have 4 y's.
Yeah, right. Absolutely. So I really like the way you started, though, where you went to the trouble of doing expanded notation there, and it got you partway to the answer, right? So I do want to look at so we're going to be talking about division of powers today. So I'm going to want to spend a little more time on this. I'm going to clear everything off the screen, and I'm going to go to the 2 patterns that we showed you to work with, and they look like this. So you can see that really Mirta wrote out this kind of a pattern, right? She followed the pattern we gave her to try and get her way to the answer, and she got really pretty close. The thing that I think tripped her up is what we were just talking about, is realizing that when you have this negative 1, it's going to end up on the bottom because you take the reciprocal and change the sign, right? So if you see here, then this would go to the bottom and that would go to the bottom, and I would end up 1, 2, 3, 4, 5 x's and 5 x's. And Mirta figured it out last time, right? These would cancel because top and bottom, they cancel. And this y would have to go up, and I would have 1, 2, 3, 4 y's. So you can absolutely do it by expanded notation, the way that Mirta looked at it, the way I showed you here in the middle. And there's a bit of a shortcut, and I'm going to tell you it right now, and we'll practice it more in our game. So what I'd like you to look at is, if you put this to the top, if you said, I'm going to take my z to the negative 2 and I'm going to take it to the top, then it would be z to the negative 2 times z to the 2. And we know when we multiply our powers that we add the exponents, so I would get z to the 0. So whether you did like Mirta and you crossed them out and you did this, it would work. Or you could simply think in your head, well, I have a negative 2 here, and if I subtract the negative 2 on the bottom, which you know is the same as adding 2, then it goes away because now I have an exponent of 0, right? And we can try that on some of the rest of these too. So for our x's, I have x to the negative 2. If I subtract 3, I get x to the negative 5, which we know is 1 over x to the 5th. And look, there's my x to the 5th in the bottom of the problem. So there's several techniques you could use. You could move the negatives to the side of the division bar where they become positive, because you know that you can do that with reciprocals. You can simply subtract the bottom from the top, or you can cross things off. The one thing to be aware of, if you are going to subtract the bottom from the top, and I'm gonna clear the screen a minute and show you with that top problem, right? This top problem here. If you are going to subtract here, so you have x squared over x to the 3rd, and you say, I'm going to subtract that 3 up here, I end up with x to the -1. You can't leave your answer like this. Your answer cannot have a negative exponent. So then you have to put it below the line and change the sign. So just keep that in mind. If you're going to do the subtraction and you end up with a negative result in the exponent, there's another step you have to take. And that was a common mistake that I've been seeing on the quiz and on the homework, is that people are forgetting to get rid of their negative exponents. Right? So be sure you're paying attention to that as you go forward. Does somebody have a question on this? And we're going to do more of these today. So, but I'd be happy to answer any questions right now. Does that make sense to you, Mirta?
Yeah, that makes sense.
Okay. How about anybody else? That helps Mirta get through why her problem, why she got a little bit stuck. What about anybody else? Because I guarantee you're going to see more of these. Okay. Well, you can all wait until the next one comes up, and then you can ask your questions then if you'd like.